Hi guys, well, it has been a while since my last video. Yeah, busy times, a lot of work. Was on a business trip in Romania, visiting Mr. Dracula himself. Well, not quite, but very near. It was in Brasov, an Alpine hotel, 1 week. Unfortunately, I didn't saw Bran, it's called the castle. And I didn't saw Dracula himself either. Anyway, back from that trip, had a nasty cold. Great, huh? And the next thing was that my firewall that I'm using, a Cisco firewall, a small one, it's starting to making troubles. The power supply is dying. And to be honest, it makes no sense to repair it. It would be easy to repair it. But the firewall is too old already. So old that I cannot use the GUI, the configuration GUI, graphical user interface, with modern browsers, because the GUI does not support the TLS version of the newer browsers. Anyway, that means time for something, new. So, and this is the purpose of this video. Good friend of mine brought me a MIKROTIK router. I was using these things way back in the 2013, 2014, excessively, as small access routers for an internet service provider. Well, he brought me this one. That's a router port 951G. It has 5 LAN ports, as we can see here. The first one is PoE capable, passive PoE. That means that this thing can be powered through PoE, power over Ethernet, but cannot power anything downstream through PoE. So it can only accept PoE, that's all. If that makes any sense what I'm saying, yeah. Anyway, this thing can be powered through PoE. It has a BGN router in it. It is quite fast. From the router port, the software is very good, comparable to the Cisco software from the feature set. Yeah, well, this is only the shell here. I opened it because it is quite cumbersome to open it, this thing. But let's start with the teardown, how this thing looks inside. So now we have, this is the motherboard, mainboard, motherboard, however you call it. Let me take something, this thing, to show you. So what do we have? We have the 5 LAN ports. First one is PoE passive capable. The DC barrel jack that accepts 8 to 30 volts input. Reset button. A very, very problematic button, because if you put too much strength, too much pressure in that, you will rip it off the board in this way. Happened many times. Anyway, let's turn it on this side. Here we see the magnetics for ports 2 to 5. And this is the magnetics, the transformer for the PoE board, because this is handled differently. As we can see here, we have 2 bridges. One goes to the PoE and one goes to the barrel connector. This is just for polarity protection. And both bridges go directly to this synchronous buck converter. I will show it to you just briefly, because we will get through all the interesting data sheets of all the interesting ICs that I found here. We go through of that. That's just a buck converter, synchronous buck converter, that makes probably the 3.3 volts. There is a second one, we're here, the same thing. I don't know exactly for what voltage, but it's the same chip. The first interesting chip is this Theros 7-port switch, LAN switch. Of course, we cannot see exactly what it is, but again, I will show you the data sheets in a jiffy after we go through this, the schematic, through the electronics here. What do we have here? Let's go a little bit back. We have two 512K bit RAMs, 512K RAMs, the dynamic RAMs. Again, we will check the data sheets. That's the flash where the whole firmware is residing. And this is the major chip here. This chip is the SoC, system on chip, that runs all the Linux, all the router, the routing, switch, the everything. This is on this chip. Again, I found the datasheet is almost 500 pages long. Wow, huh? Anyway, but we will not get through the 500 pages, just to see what this thing is capable of. Here we can see this meanders here to match the length of all the data and address lines from the memory chips to the SoC. If we continue, here we have an EEPROM, that's probably for the configuration, that holds the configuration. And then we continue to the Wi-Fi part. We have two antennas, embedded antennas, wing, wing, wing. But we have an additional UFL connector here, so you can use this kind of pigtails for external antennas. For example, this is an SMA or an RP SMA, reverse polarity SMA. The difference is that instead of having a hole here, it would have a pin. So, I just removed the shielding from one of the two parts. We see here that the path goes from the output of the SoC, the transmit part, to this power amplifier. I have the data sheets, I will show it to you. And the output of the power amplifier, that is up to 30 dBm, goes to this power switch. This power switch is very difficult to see. I don't know if we can read it. No, not really. Yeah, we can. One side, one input port goes to the power amplifier, the output of the power amplifier, and the other side goes to the RX part, directly back to the SoC here, as we can see. And the output goes one time to the UFL connector, and goes through the UFL connector here to this embedded antenna, and it has an additional footprint for, I think, for an SMA connector here. The same thing exactly happens on the other side too, as you can see here. So yeah, that's a beeper, that's a power MOSFET, I don't know exactly for what it is. And that's more or less the whole thing here. This is the cooling heatsink for the power amplifiers and the SoC chip additionally. Yeah, well, that's how it looks inside. Additional USB port. These things are quite powerful. This is not the newest one, the newest MIKROTIK version, but it is powerful enough for everything that I would like to use it for. Let me show you how this router or this switch, router, whatever you call it, will be used. And we lost the focus. Here we are again. So, the connectivity I have in my configuration here at home looks like that. We have the internet provider. Then I have a Cisco router as an VDSL connectivity endpoint. Then I have here the firewall itself with port address translation. This is the MIKROTIK, will be the MIKROTIK. Now it's again a Cisco firewall, a small one that is dying. And behind that I have the switch, a layer 2 switch, where all my hosts rely at the moment. So, and this is exactly what will be changed. It's, and from a Cisco something that it is 10 or 15 years old, will come to a newer one, will be changed with a new one, with this MIKROTIK that is capable enough for everything. What I will use port address translation or interface overloading or masquerading, call it however you want. It's more or less the same thing. It is a kind of source address NAT, but using only one external address, either a loopback or the external interface address, and converting the sessions to different ports. So this is for by the way, how Cisco saved the internet all these years with the PIX firewall and the NAT path, because this gave IP version 4 the capability to live till now. Otherwise, we would have problems. The good thing is, the whole thing does nothing else. You have a private IP space, for example, 192.168.xx something, and you have the whole LAN, the whole caboodle behind this firewall, and at the end, you use only one official IPv4 address, and that's it. So you hide all this LAN behind one IP address. First of all, it's a security thing that you cannot make direct connection from outside to inside, and it saves million addresses. Yeah. At the time where the internet started to run, everybody said, yeah, I will take part on the internet, give me an address range. And everybody, the first one, got class A addresses, that was million addresses, yeah? Or then class B, 64,000 IP addresses for nothing, yeah? I don't know, these companies that still have this class E ranges, most of them use them to I don't know, give an IP address to the toilet seat of each of each toilet. I don't know, because there are so many. Of course, many are from the government, military, etc. But there are many others that said at that time, okay, give it to us. HP, for example, yeah. They don't need a class A address, not in the today time. The good thing is that they're starting to, that these big ranges, these big blocks, starting to coming back, and this is why we still have IP version 4 functionality, and IP version 6 is still not deployed completely. Otherwise, now we would have IP version 6 and much fun with the big unrememberable addresses. Anyway, this is blah blah again. I'm taking your time. Anyway, this is the connectivity what I'm going to do. And this will be shown in a second video, how we'll configure this thing, this MIKROTIK. By the way, I closed it again. This is how it looks closed. What about focus? Okay, now we have it again. To have here, yeah, I forgot here that I still have a firewall, Wi-Fi. This thing is, of course, not 5 gigahertz, only 2.4 gigahertz BGN. But it's enough for what I'm doing. I don't need 5 gigahertz at the moment. So let's continue to the datasheet and a little bit more information on the ICs, the interesting ICs themselves. And in the next video, I will show you the configuration and how this thing works. So, before we check the ICs and the interesting hardware that's inside this small router, let's go in fast forward through the specifications. I'm using the RB951G-2HnD, that's mine. Has 5 gigabit boards that can support 10 and 100 speeds too. The Wi-Fi supports BGN standards. We have, of course, a beeper. This is very important. Yeah. The core chip that here is called CPU is wrong. It's not a CPU. For example, the CPU is only a part of this chip. This chip is called SoC, or System on Chip, and is a conglomerate of CPU, of memory controllers, of switch, of integrated switch controller and serial controllers, SPI, I2C. I will show it to you in a jiffy in more details what inside from the datasheet. And it has the CPU integrated too, yeah, plus hardware accelerators, plus Wi-Fi, the MAC layer, and the Wi-Fi front end, etc. This is the heart. This thing is the heart of the system. This is where the magic happens. This is where Linux runs, Linux, or however you call it, yeah, because the operating system is Linux based. Anyway, it has only one core, so it's not a hypersonic rocket, and it's clocked with 600 megahertz. The MIKROTIK can be supplied with a voltage between 8 and 30 volts. It can be supplied either through the jack connector, the barrel connector. Let me make it smaller here. This thing here, the barrel connector. Or it can be supplied by using PoE through LAN port 1. Only LAN port 1 is passive PoE capable, and this is this first port here. So what means passive PoE? Does that mean that, wow, this thing is PoE and can support other downstream devices too? No. Passive PoE means that only the MIKROTIK himself can be supplied from an external voltage that comes through the LAN port 1 in a PoE standard. if the MIKROTIK would have to support downstream devices, then it would be active PoE, power over Ethernet, and it would need a much more powerful power supply than this toy wall-wart adapter that is delivered with. So what else do we have? We have DDR2 dynamic RAM of 128 megabytes and a flash, again with the same size, 128 megabytes. So then we come directly to the second most important chip on this board. That's the switcher. The switch itself, the switch fabric, where all the high-speed switching and forwarding of the ports to the from and to the ports, LAN ports happen. Then here we have some information about the Wi-Fi levels. It is not something that you will call home here. That's a TX in dBm, dB milliwatt, decibel milliwatt, yeah, and that's the RX level of sensitivity, again in dBm. Yeah. You can see that it is quite sensible. The sensitivity is quite high if you use only 6 megabit and the transmit power is 30 dBm for 6 megabits, but who uses 6 megabits? Yeah. And even at 54 megabits, it falls down to 25 dBm, and the sensitivity is down already to minus 80 dBm. Yeah, what else? Here we have a USB. It's host and I don't know what the other name is. It can play host and it can play anyway, both types. Sorry, I don't know, I forgot the other name. That's it, more or less. So let's go to the board again. The power comes here through the barrel connector or through the LAN port 1 through this LAN magnetic transformer. Here we have the 5 ports. That's a module with five LAN RG45 ports. Here you have the LAN magnetics for the ports 2 to 5, and this is the magnetic transformer for the port 1 that is used for passive PoE. I do not exactly know why these 2 bridges are here. One theory would be because of polarity protection. I don't know. But the other interesting thing is this buck converter chip. This is a synchronous buck converter chip from Liteon. But this one has a maximum input voltage of 25 volts, absolute maximum ratings. Operational rating is up to 23 volts. But in the characteristics, in the datasheet, it says this thing, the MIKROTIK itself, can be supplied between 8 and 30 volts. So there have to be somewhere or something that clips down the voltage to, let's say, 23 volts. I don't see anything here, to be honest. I see only this DVS diode here. This is the one that is doing the magic. I don't know, but I cannot imagine, because then if you supply this with 30 volts, then this diode or whatever circuitry is in here that clamps the voltage down to 23 volts or something like that has to be active all the time at 30 volts or at a higher voltage of this clamping device. The difference between the clamp voltage and the maximum input voltage has to go somewhere in heat. So I do not know where the clamping happens, but it has to be somewhere. Yeah, I didn't find anything. In my opinion, this is the major supply. That's or the 3.3 volt, 3.3 or 5 volt supply. And then you have a second one here, this thing here. It's again the same synchronous buck converter, but with a different inductor. Here you have 4.7 microhenry. That means you probably will have more current, but more ripple. And here you will have less current and less ripple. I don't know what this one is used and what's the output voltage. Anyway, now we are speaking about the synchronous buck converter. Let me show you a data sheet. This is how it looks. The connectivity is quite an old one. We have a date here. Yeah, not that bad, 22. So it is still used at 2022. That doesn't mean that it came out 22. Yeah, this is, I don't know which version of the, does it say any version? Revision 9. Yeah, it is quite old. It's quite new, this data sheet. Yeah, the internals. And here you see 4.5 to 23 volts. So somewhere has to be the clamping, but anyway, I do not know where. The next thing, this is just the power MOSFET. Again, I do not know why. Is this thing doing the clamping? Would be an option in combination with a Zener diode, blah blah blah, like a regulator, for example, yeah, because this thing is quite powerful. Then the next chips of interest are these two DDR2 RAMs. They are organized in 512 megbit by 8. Both of them. In total, you have 1 megbit by 8, and at the end you have 128 megabytes of RAM. 1 megabit is 1024 divided by 8, you get 128, and that's a megabyte. Same thing for the flash. It's a 1 megabit. Sorry guys, absolutely bullshit what I'm speaking. Not megabit, gigabit. This is 512 megabit. That takes 1 gigabit. Yeah, and this is in total. And if you divide it by 8, you have 128 megabytes. Complicated. Anyway, this is a 1 gigabit flash again, NAND flash. Again, divided by 8 bits, you have 128 megabytes. Let's have a look of the SLC NAND flash. This is how it is organized, 101 gigabit. Both of them are from WinBond. I used a lot of devices from them. The second thing is a DDR2 RAM, again from WinBond. It's a BGA. This one is a TSOP48 device that has the pins on the sides, and the BGA has balls, solder balls that are on the bottom side of the chip. Yeah, that's a DDR2 RAM, nothing really special. I'm not sure if we have here quite a lot of supply voltage is needed, but the SoC, the system on chip, has a lot of regulators on it, and one of them is for the 1.8 volt too. We will see it later. So what do we have? Let's continue. Let's go. No, let's take another. This is the second switch mode controller, the same one like this one that I showed you. This is an I2C EEPROM. That's for the configuration. That holds the configuration. Serially connected through I2C to the SoC chip. And this is the heart of the system. That's the SoC chip itself. And that's a beast. Let me show you.
the datasheet of the AR9344 from Atheros is almost 500 pages. 500 pages, yeah. But it has a lot of stuff inside. It's nothing to do with only a CPU, yeah. For example, here it says it includes a MIPS 74KC processor. Includes, yeah. This is only a part of the SoC chip itself. Here we see, let's make it a little bit bigger, more or less the internal architecture. You have a complete RF front end. You have the MAC layer of the wireless. You have the flash and DRAM controllers, interface memory controllers. Yeah. You have Ethernet interfaces. You have a fast Ethernet 5 switch as onboard switch with 5 fast Ethernet ports. Not sure if this is used, but I don't think so, because there is an external switch chip that is used on for the MIKROTIK. Then you have the processor itself, accelerators, and a lot of interfaces. USB, UARTs, high speed and low speed, PCI Express, I2C, doesn't have a SP, interesting, and even for VoIP connectivity. So a lot of stuff. This is the heart of the system. This is where the Linux runs. This is where the magic happens. This is what everything is. This is the core chip of the whole MIKROTIK. This is the MIKROTIK, more or less. Yeah. Then you have here the second important chip. This is the switch, the LAN switch itself. You see how many traces are going here, connecting through the SoC to the switch chip itself. They go to the magnetics, to the LAN ports. Yeah. And here you have this meander stuff to get the same length for all the lines you are connecting here. So you have the same speed that data go through these data lines. Where am I now? Okay, I'm at the LAN chip. Let's check the LAN chip. It's the AR8327, 7-port gigabit Ethernet switch. We're using only 5 of them. And it looks like that internally. You have, here happens all the switching and forwarding, high speed magic. That's it. And here it goes out to the physical layer, from the physical layer to the magnetics, to the RG45 ports, etc. And here, this is the connectivity directly to the SoC chip. Very interesting. Then, the next thing we have is the RF part. And the RF part is here. These are 2 modules, 2 blocks, identical blocks, because the SoC, the RF front end, can support 2 antennas. And we are not using the power of the SoC, the transmit power is too low for the designers of the MIKROTIK to go directly out to the antennas. So they are using, let's take it again somewhere higher. They're using, you see that? Anyway, this line here goes from the SoC directly to this chip. This chip is a power amplifier. And the power amplifier, the output goes through this chip. And this chip is a power RF switch that has 2 inputs or 2 outputs and 1 input. However you see it, it's symmetrical. Yeah, it's a switch. The one side goes through the power amplifier that can deliver up to 30 dBm, unmodulated and modulated with ODFM between 23 and 27 dBm, goes to the switch, and then you have one output that goes either to an footprint that it is for a connector for an external antenna, or through this path here that again is interrupted. In this, between this path is an UFL connector, so you can use the UFL to SMA or RP SMA. RP is for reverse polarity SMA. Pigtails for external antennas, and it goes then directly to the impeded, one of the impeded antennas. The other side of the switch goes back to the SoC, and that's the RX part, receive part. And you have the same thing on for the other antenna too. So there's nothing much more to say here. Here you have the beeper, very important beeper, and the USB-A connector, the clock for the SoC, and I don't know for what this crystal is, probably the clock for this switch. Let's have a look on the power amplifier, the RF power amplifier. It is quite an old unit, 2012, but it is okay, it works. It goes up to, I was too low here. This is how it looks internally. You can control the output, the power output through VCC0, VCC1 and VCC2. Here does it look, it's a QFN package. 16-pin QFN package. And here you have somewhere here. This is the output power. As I said, it would be without modulation, it would be 30 dBm, as you have it here in the P1 compression point. But if you start with the modulation, you have it between the ODFM modulation or some other modulation, you have between 23 to 27 dBm. Yeah, that's it for the power amplifier. Then we have the switch here. It's again a really old one, 2004. It's phased out and drop-in replacement, blah blah. And it is nothing special here. You have two outputs or two inputs, because this is symmetrically, an output is symmetrical here. So you can have either one output, that it is more the reality, or and two inputs, TX, RX, an antenna, for example. Yeah, this is how it looks. It is very straightforward. Well, that's for the hardware.
Okay, that was it for today. I hope you liked this video. It's a little bit different than just only designs and pure electronics. My second job, or my primary job, is network design. So I use a lot of these things, and Cisco and Palo Alto and blah, 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 many things anyway. Don't forget to give me a thumbs up, please. Subscribe to my channel. This will help me a lot to grow my channel and to give me the possibility to show you more of a variety of different themes. And press the bell button so you will get informed when I have new videos. Guys, please subscribe. It will help me a lot. So, I wish you all the best. Please stay safe, my friends. Cheers. Bye.